welcome to this will be day 5 of our Power BI Bootcamp, and we are happy that you joined. Today we have somebody special in our midst. His name is Ashraf. He is a Microsoft MVP and is also the community lead for the Toronto Fabric and Power BI user group. Is somebody that is well known in the community. You can connect with him on LinkedIn. You can connect with him on LinkedIn. Yes, I think LinkedIn is the most,
Yeah,
professional way to connect with somebody.
yeah,
And it's somebody that is always ready to help. He's a community person. You can always reach out to him anytime, right?
yes.
We are happy to have you here, Ashraf. Thank you for taking your time to be here today, despite
Thanks.
your busy schedule. Despite that it's the weekend, we really appreciate it. Today we have a very interesting topic that we are dealing with, which is the dimensional data modeling in Power BI. And this topic is very important because, in fact, I would say that it embeds most of the important areas of Power BI, even in terms of performance, even in terms of everything you do. The model part is something that you cannot run away from, and a deep understanding of it will really help to determine how your Power BI report is going to respond, how it's going to load, how it's going to refresh, and a whole lot of other things that are embedded, inside of the Power BI data model. So, guys, I present Ashraf to you today to take us on dimensional modeling. Thank you so much.
Thanks, Benga, so much. Thanks, everyone, for being here today. And thanks, Benga, again, for inviting me to be part of your journey toward learning Power BI. And yeah, I'm happy to be here with you today to talk about one of my special topics and also my favorite topics, which is about dimensional modeling and Power BI. Um, so as you notice here, the slide deck here is based on a very old slide deck template because the reason for that is that was because one of my very early topics I delivered about Power BI back in 2017 in Power BI World Tour. It was a global conference at the time, and it went to multiple cities, as you see at the top here: London, Copenhagen, Toronto, New York, Chicago, San Francisco, and Sydney. And I delivered actually this session the first time was in the Toronto event. So that's why I decided to keep the template because it's so special template for me because as I told you, it was one of my very early topics that I delivered in about Power BI. Okay, so a little bit background about myself. Again, as my friend Benga said, I am the leader of the Toronto Fabric and Power BI user group. And my background is I have been in this domain for 20 plus years in the area of like different areas, basically strategy management, process improvement, performance measurement, and obviously data analytics as a key enabler to inform all those management disciplines. I have diverse industries. I work in so many countries. I'm originally from the Middle East. So I worked in the Middle East, I worked in North America, and I also had some project in Europe and the United States as well. I'm one of the 12 MVPs in data platform based in Canada. So I'm so proud to be one of them. And I'm a co-author of 2 books. I'll talk about those 2 books shortly. And I'm a frequent data analytics speaker in so many events. My educational background, I have a bachelor degree in computer engineering and science, and also I did my MBA in strategy management. I'm a certified Lean Six Sigma Black Belt certified, project management certified, and also MCT, Microsoft MCT, certified Microsoft trainer. And when it comes to Fabric and Power BI, I'm a certified Fabric Analytics engineer, data engineer, as well as Power BI data analyst. Okay, those are the 2 books that I mentioned earlier. Those books were written by MVPs from all over the world, and every MVP wrote a specific chapter in this book. And the chapter I wrote in this book was about the AutoML capabilities inside Power BI. And the other book is the Microsoft AI MVP book, again, written by MVPs. And the chapter I wrote in this book was about AI and cognitive services capabilities inside Power BI. They are relatively old books, to be honest with you now, because they were written back in 2019. But if you are in your early stage of learning about Power BI and AI, you can check out those books. They are available in Amazon, and they can give you a really good foundation, actually. And the royalty that comes from those books, it goes to charity. So you're not going to make me rich by buying those books now. So, but I really encourage you to check them out, guys, if you are at a very early stage of your journey. Okay, cool. So, by the way, I would love this session to be interactive. So if you guys have any questions, feel free to interrupt me or come off mute and ask your question, or also use the chat or the Q&A. I'm not sure about your protocol here of using Teams, whether you prefer to use the chat or the Q&A section. It's really up to you. I leave that to you guys to decide, or Benga. I appreciate if you can monitor that, and if you have any questions, let me know, please. Okay, so the objective of our session today is to introduce the basics of how to build and manage the data model in Power BI. And this is the agenda, introduction to data models, different types of data models, how to manage a relationship, how to add missing dimensions, and enhance your model. So since the context for teaching the concept of data modeling inside Power BI is relevant to Power BI, so it's really important also to understand your journey so far. So your journey starts, the very early starting point when you deal with Power BI, you start with getting the data phase, which is basically using the Power Query editor to ingest the data, identify all your data sources, do the data integration, do the data profiling, understand the distribution of each value inside each column, understand how your data is distributed, identify any data quality issues or any missing value, do all the data transformation, data manipulation, data integration, etc. All of that is being done already in Power Query Editor as a first stage in Power BI. Then after you are done with this stage completely, you move to the second stage, which is very, very critical stage as well, which is the data model. And in the data modeling inside Power BI Desktop, you build the fact and dimensions, which is the basic principle of the dimensional model, and we will talk about that in a minute. And also you manage the relationship, which is identifying the relationships between those tables, because that's a very, very important step to understand exactly how the tables interact and should interact with each other, and what is the relationship between those two tables or different tables or multiple tables. Then after we are done with this stage, another critical important step before you jump to the reporting layer, which is how to enhance the data model by enriching the data model by adding calculations, which calculated columns and measures using DAX. And this is very important because, as you know, the data, when we ingest the data from its source, whatever the source is, it's very transactional in nature, very raw, very transactional, very granular, which is not, sometimes is not the best starting point for reporting layer, because the reporting layer is meant to take that to the next level. That's why the calculation can be extremely important to enrich your data and identify certain measures and KPIs and certain calculation and aggregations, and do some analysis over time, like how to compare the current year versus last year, how to do or visualize actually the growth over time, how to do the percentage, etc. So calculations inside Power BI is extremely important using DAX, which is the next step after we are done with the modeling stage. Then you proceed with the very last stage, which is the visualization, which is the ultimate objective of using Power BI, because everyone is interested actually in visualizing the data and see the data in visual way, and also maintain the interaction between different visuals inside your Power BI report. So that's basically in a very simple diagram is your journey from ingesting the data all the way long to visualizing the data. I believe already you guys like did a good job so far in your learning journey with my friend Pinga. You covered already first stage completely with Power Query and Power Query Editor ingesting the data, and you understand now how to manipulate and handle the data and different types of data and different types of data issues and integration and how to merge table, how to integrate tables, how to combine tables, etc., and how to build tables. All of that is really like good foundation for us to proceed to the stage that we are at now, which is the data modeling inside Power BI. Okay, so data modeling. So what is data model basically? So a Power BI data model is a collection of tables connected with relationships, which is enable actually your business user to easily understand and explore their data to get business insights. Okay, so that's the very basic definition of what we mean by data model inside Power BI. Okay, why a data model is important? Because it makes your data available for reporting, right? That's the very starting point. We need to present the data now. Like we are done all the work that we did previously was already in the back end. You were in the kitchen, right? You were preparing the raw data, dealing with the raw data, raw tables, etc. Now we need to take it to the next level. We need to actually start exposing the data and present the data to the business. Okay. One big difference also, when you deal with the data source and ingest the data in Power Query Editor, most of the times that you are dealing with the naming convention that is driven by the technical needs and the data source system. When you start actually presenting the data in the data model, that's your opportunity now to change the naming convention from being technically driven naming convention to become business driven naming convention. So make the table's name more business meaningful. Make the column name are more business meaningful. So you are now bringing the data again from the technical, deep technical data sources that is driven by technical requirement to become more business friendly and more intuitive to the business. Also, it's important because it's the starting point to present actually correct numbers through calculations and measures. Because if you don't have a good model or a good data model, that can impact actually your calculations and measures, and it can actually lead to some inaccurate measures, even though the measure is working from a syntax perspective, but sometimes it doesn't actually provide the right data because you can have duplication in certain tables, for example, or so many null values or missing value, etc. So there could be so many issues if you cannot handle properly in the modeling stage. You may need actually or end up with inaccurate calculations and measures in the next stage. Also make the report design and the use of visual much easier, right? Because if the aim for us is to simplify the model and make it like streamline actually the reporting layer, because this is very important. Because if you don't have a good data model and you have very cumbersome data model in the back end, it can make your life much difficult when it comes to reporting and visualization. And you have to handle so many awkward situation using very complex DAX, which is not good. So your best interest as a report designer is to simplify your model as much as you can, streamline your report as much as you can, make it as easy, straightforward as much as you can, because trust me, it will make your life much easier in the next stage when it comes to calculations and the reporting and visualization as well. So very important step in our Power BI report. Also, poor data model can have impact on the performance of your report as well. Because if you end up with very cumbersome, complex data model behind the scene, you may need to do so many joins actually to allow the data to interact with each other, which can severely impact the performance of the report, and it can slow down your report because your data model is very cumbersome. So many tables, you need to do so many joins, etc. So your best interest is actually to simplify the model, as I mentioned, minimize the number of tables as much as you can, go close to the star schema as much as possible, because that's the simplest model, and we'll talk about it in a minute. Because it also not because it's a fun to have it, but because it's important to have that from a performance perspective. Because as I told you, cumbersome data model can lead to a poor performance report and can slow down the interaction inside the report as well, because of the multiple joins that you need to go through to get the data that you want. The other area also that can negatively impact actually the performance of your report if you have a cumbersome data model is the complex DEX calculation and measures, right? Because you may end up with a core situation that requires also very complex DAX to handle those cumbersome situations with multiple joins, redundancy, duplicate values, etc. If you don't handle that proactively upfront, you may need to handle that in the DAX measures and DAX calculation, which can make your DAX calculation measure very cumbersome, very slow to calculate, and also will impact actually the performance of your report and the interaction of your report, and it can slow down your report significantly as well. So last but not least, or at the end, actually, after you do all that work, it's actually very beneficial for you to increase the user adoptions, right? Because that's, again, your ultimate objective of building the report is to make sure that it's being used by the business. People, they love to use it. It's so fast, it's so responsive, it's so very interactive. And as a result, you need to, you will achieve actually the higher adoption level from our business users. Okay, so keep in mind, not every data model in Power BI is a good model. Like everyone has a data model in Power BI, right? That's a fact. When you say data model, every single report has a data model. But you have to understand also, not every model is a good model, because there can be a good model or a bad model. So now the focus for us, how to make sure that your model is a good model. Any questions for so far, guys? I'm going so fast, or the pace is okay?
So you're going so fast. Good afternoon.
I'm going so fast?
Yeah.
I slow down.
But
I'm going so fast with delivering the content, or going so fast with my talk?
with your talk.
My talk? Okay, I'll slow down then. Okay. Thanks for letting me know. Okay, any other questions or comment or feedback before we proceed any further? Okay, cool.
Hey, good morning. I'm sorry.
No, oh yeah, good morning.
We hear a lot about ETL process when looking around in these type of models. It is related with this data model, this ETL process?
ETL is a broader term in the data warehouse domain. And ETL, when you break it down to like the key stages actually in the ETL, starts with E, it stands for extract, T, transform, L is load, right? So
Okay.
E, and if you need to translate that or map that to what we do in Power BI, the E side is basically what you have covered so far with my friend Banga, which is the Power Query editor and how to ingest the data, how to transform the data, how to manipulate the data, etc., right? Then after that, you go to the load stage. Sorry, the transformation stage, which also can be done or done in Power Query Editor and Power Query using Power Query Editor. So transformation also is the stage where we need to do some data transformation and data manipulation to build our data model inside Power BI. Then after that, you load, which is the loading of the process actually to the final destination, actually, which can be the visualization piece. That's assuming that actually you implement the ETL within Power BI. But as I told you, the ETL as a term comes from the data warehouse process. So if you are simulating actually the process of building a data warehouse inside Power BI, that's how we can understand it. But in ideal perfect world, you should have already a data warehouse as a data source for your Power BI. So you have to be mindful here. What is your level of maturity and level of sophistication in your organization? Are you the ETL person and using Power BI to do ETL for this specific report, which means you go to the all the way long to the actual data source and do the ETL process inside Power BI to do the visualization? That can happen in certain cases and certain scenarios and certain organizations. Or is there a data warehouse already that does that for you? It builds already the ETL before you populate your data warehouse with your data, then your role as a Power BI reporter or designer is to go to the data warehouse and ingest the data already that is already transformed and ready for you to use with the data modeling already in place. Like in the fact and dimensions already are built in the data warehouse. So that's a very good question, very critical question, and you need you guys to understand exactly, yeah, where do you work and what kind of organization do you work for, and do they have a data warehouse that takes care of the ETL process already, and they build already the dimensional model and fact and dimensions already in the data warehouse. Then you can, your responsibility is just to go and ingest that and build your report, or you are simulating the whole process and building your own ETL from scratch inside Power BI. I'm not sure if that answers your question or not.
Sure. Great. Thank you very much.
You're welcome. Okay, another question.
Okay, I just wanted to plead with you. The facilitator has also highlighted what I wanted to say. I want you to recognize that some of us are beginners, very, very new to this particular program. So some of the acronym you will be using, if you can just make us understand so that we can also benefit from this level of education. So we appreciate.
Enough.
Then also, I'll also plead with you once more. The pace is still too fast for us. We hope to catch up. That's what I promise you. But the pace is fast for us.
Okay, so I'll try to slow down. Sorry about that. I'll try to slow down. And if I use any term or any acronym, like without paying attention, please stop me and ask me or put it in the chat, please. Okay, so the ETL we were just talking about now stands for extract, transformation, and load, which is a very common term in the data warehouse and our process as a report designer. Okay, any other questions or comment or feedback before we proceed any further? Okay, cool. So let us now talk about like what is the different types of data model. Because again, as I told you, there are multiple types of data model. So we'll start with the very basic one, which majority of you can relate to or understand, which is the flat or denormalized table, which is basically you have all the information that you need inside just one table that has all the fields and all the columns that you need in just one table, which can be the very common case when you deal with Excel sheet, for example, or you come from Excel background. A very common scenario. All the data that you have in just one table. Someone give you one table, single table, that has all the information inside this table. So that's what we call it flat table. It's one table. And we call it also denormalized. Denormalized because it has all the data repeated over and over again, because as a result, actually, when you combine multiple fields in one table, you have to end up with some duplication here. Okay. So for example, if your table has a sales transaction, correct? And the sales transaction could be millions of sales transaction inside the organization. But also inside this table, you have all the information about every single client who purchased those sales transactions. That means all the client information, including the name of the client, the address of the client, the phone number of the client, the email address of the client, and so on. All the information about the client will be repeated over and over again with every single sales transaction associated with this client. Okay. That's the nature of the flat file, the denormalized file, flat file. So all the information is repeated over and over again with every single sales transaction. Imagine if we have millions of sales transactions. That means my information will be repeated million times because I have million record in the sales table. Okay, that's the flat denormalized. Why? What is the benefit of the flat denormalized? It's simple, straightforward. You don't have to worry about the relationship. You don't have to worry about the normalization. You don't have to worry about like how the tables are connected with each other, how the relationships are connected with each other. You don't have to worry about all of that because all the information that you need is just inside one table. The disadvantage is the duplication, redundancy, because again, go back to this example. If you have millions table with millions of record in sales transaction, and you happen to have the information about the customer is already associated with every single sales transaction, that means as a result, the sales, every single sales transaction will be associated with my information repeated million of times as well, because I have million record transactions, sales transactions, which is not good. Simple, straightforward. You don't have to worry about the relationships, etc. You don't need to understand the concept of relationships or data modeling. You have all the information in the table, but at the same time, it's causing actually the size of your table to become so big, and the number of redundant information is so big as well, because again, all the information about the customer will be repeated millions of times, which can increase the size of your table and also can have negative impact on the performance of your report, because you have to process a very, very big data with millions of records and millions of columns, with so many of the records are repeating the same information over and over again. Then the second type here, which is the best practice actually, and that will be our focus for our session today, is the star schema. So if you hear the word star schema or dimensional model, those are like, it's basically same thing, which can be, this term can be used interchangeably, star schema or dimensional model, or fact and dimensions, or fact and dims. All those terms, they refer to the same thing, which is star schema, which is the second type of data model. And we will talk in a minute now, in the second slide or in the next slide, why it's called the star schema and what is exactly the star schema. Then the last one, which is the snowflake, which is like the next level of the star schema. It's like the star schema, but it is the dimensions in the star schema are a little bit denormalized, and it's like extension of star schema where some dimensions are more denormalized and more extended. So you have multiple layers of dimensions before you hit the fact table. Of course, that is not clear to understand now because you still need to understand the star schema first before you understand the snowflake schema. But just keep in mind, those are the three types of data model. Flat, denormalized, very common. If you come from Excel background, star schema, we will talk about it in a minute. Then the snowflake is just the extension of the star schema. So let us cover now what is the star schema first before we can go back and elaborate more on the snowflake schema. Okay, so what is star schema? Star schema is basically the simplest style of data model schema, and it's is the approach that most widely used to develop dimensional data warehouse and data marts, right? So the concept comes from actually data warehouse and data marts. And this is a very simplest, very straightforward concept, and also it's a best practice because it has so many benefits when it comes to optimization of your model and how to optimize actually dealing with your tables, how to minimize the number of joins as much as possible, because we said that right from the beginning, our best interest is to minimize the number of tables that we deal with as much as we can, to minimize the number of joins as much as we can, and also remove redundant record as much as we can, and optimize the DAX calculations and measures as much as we can. That's our ultimate objective here. So what is the starting point to enable us to do all of that is to make sure our data is designed around the principle or the concept of the star schema. Okay. So why is it called the star then? Okay, guess what? Because it's technically looks like a star. That's why the term star schema comes from. See, that's it. With all the variation of star schema, trust me, all of them will eventually look like something like that. Okay, what is that shape basically? So the shape is starting with, as you notice here, a core table in the middle. And this core table in the middle, we call it fact table. Okay. And what is the fact table basically? The fact table typically is the table that has all the granular business transaction in your business process. For example, you can work in a retail company where all the sales transaction is captured inside the sales table. Every single sales transaction is already stored and captured in the sales table. If you work in inventory, for example, all the inventory transactions in and out of your every item in the inventory or the warehouse is a transactional table, and it's your fact table in your star scheme. Any service, any customer case service, any complaint, any phone call when you deal with the phone company, every single bank transaction, deposit and withdraw is considered a fact table transaction. Any interaction between your organization and any external body or entity within the organization is considered a transactional table. Okay, so basically any call center, for example, any interaction with the call center is considered as a transaction, business transaction. So fact, think about your business and the business that you are in. Any interaction your organization is doing with or doing with any entity that the organization deal with is considered as a business transaction and eventually has to be stored in a fact table. Okay. Also, fact table is the logical home for the numerical measures that your organization is interested in aggregating to show the business value. So, for example, in the sales domain, our ultimate objective in the sales business is to do what? In the retail business or sales business is to do what? Is to understand actually our total sales. Okay. Is to understand like the sales account, like how many sales transactions we have this year versus last year versus this month, last month, and so on. So if we work in the sales domain, our core measure is the sales amount, right? Well, or counts, basically, sales counts, how many sales transactions we have, what is the most frequently purchased items, etc. So all our reports will be around that concept. If we are working in a call center, for example, the majority of our measures will be around how many calls, how many calls we have within the call center, what is the duration for each call, right? What is the result for each call? How many calls were ended successfully? How many calls needed to be escalated, etc. So all those key measures that you eventually need to capture as a KPI in your Power BI report, trust me, they will come from your core table, which is the fact transactional table in your side there. That's why we call it fact table. So fact table is basically capture the incidents, the event in your organization, your core business transaction, and it's the logical home for all the KPIs and measures that you would eventually need to present in your organization. That's why we call it fact table. Okay. Then the fact table here is surrounded by a bunch of other tables. We call them dimensional tables or dimension tables or DIM table for short, DIM table. Okay. I'm using all different terms that you may encounter later on or come across later on. So I'm helping you now to build the association between, if you come across any of those terms, how you do the translation in your mind to what we are presenting today. So DIM table basically is or a dimensional table. It contains the context actually for the business transaction. And also it has all the categorical data and categorical attributes that we need actually to filter, to narrow down the data further, or we need to aggregate the data to a higher level, So oftentimes we use the information that we have in the dimensional table to aggregate the data to a higher level, drill down or roll up or break down the data or roll it up. It depends on the level of granularity that we are interested in. Okay, so And also we use it to filter the data further. We need to narrow down the data further. So for example, in the sales context here, we are interested, actually consider the fact table has all the information about our sales. But in dimensional table, we break down the dimensional into logical entities. So as you notice here in this screenshot here, every single dimension, the focus on a specific entity in the organization. Entity. These entities are very important to allow us to break down the total sales transaction further. So one of the entity here in the dimensional table is the customer. So we need to break down the data based on all the information we know about the customer. Where the customer are from, what is the gender of the customer, what is the average age of our customers, what is the average income of our customers, and so on. So any geographical information we have about the customer. So all the information that is related to the customer as an entity is captured in the customer dimension or the customer table. Similarly, all the information about the product, like what is the product name, the product category, the cost of the product, the price of the product, the color of the product, the brand of the product, and so on. So all the characteristics and attributes that we know about the product should be captured already in the entity called the product. Why? Because I don't want to repeat the same information over and over again with the million sales transaction. I need to capture the information that we know about the product once, because every single product is a unique product. Every single customer is a unique customer in the dimensional table. You list that customer there once. I am, as an entity in the organization, Ashraf Ghunaim, I am listed there in the customer table with one record only that has all the information that you know about me. I don't need to repeat all my information millions of times with the million sales transaction that I generated. Similar to that, the product. Product is the product. It's the master data. It should have all the information, unique information that we know about the product, all the attributes. It should be about the product, and so on. So I'm not going to go through all the dimensions here, but I hope you can understand exactly what is the difference between a dimension table where you need to use these attributes to filter the data further or aggregate the data to a higher level, versus the fact table, which has all the transaction in your organization. It depends on the nature of the of your business. Okay. So as you see here, some examples here is like we need to see the sales by product, for example, or what is the most like top 5 product that we sell, or by certain locations. So what is our sales in certain region versus another region, and how to compare the sales in Canada versus the sales in the United States, etc. Or the salesperson, or the promotion, which sales transaction is associated with what kind of promotions, etc. So that's now the key difference between the fact, which is a very business transactional data, which is the logical home for all our business measures, versus the dimension where it has the master data in certain entities, and each one of those entities is responsible for filtering the data further. So we use the filter from the dimension to have focus on subset of the data instead of dealing with the entire superset in the fact table. Because once you narrow down, we need to see the sales transaction in Canada. Canada means what? Canada means we need to narrow down the sales transaction for a subset of the data which is relevant to Canada, versus the United States, which is another subset of the data. To do that comparison at a subset level of the data, that's where you need actually to build the association between a dimension and fact, which take us to the second or the third area that we need to understand. And by the way, also keep in mind, each one of those dimensions is related to one of the key questions that we need to ask about our data. It basically capture all those dimensions. They capture the key fundamental question about our business. So it answer any question about the what. What did we sell, for example? What is the product? Whom, like who saw was the person who sold bought this item from our organization? To who? That's the customer side. Where, in what location, in what store, in what province, in what city, etc. Who did the sales transaction? The salesperson. Why? As a result of this promotion, etc. So as you see here, the responsibility of the dimensional table is to allow us to answer those fundamental questions about every single sales transaction that we have in the fact table. What, who, where, why, and more. Okay, so that's another also way to understand exactly how to differentiate between what is fact and what is dimensions. Okay, so it's a master data that answers the fundamental question about what, who, where, and then the last piece here in the dimensional model or any data modeling in general is the relationship, because every single table has association somehow with the fact table. That's where we need actually to use this relationship to break down our millions of record sales transactions further to a specific region, to a specific product, to a specific location, for a specific salesperson, etc. That's what we call it relationships. Okay. And the relationship basically is the anchor. It's the association is the column from the dimension table, which is the key from the dimension table, the primary key in the dimensional table to become a foreign key in the sales transactional table. That's the association. So in the sales table, expect to see a location ID, for example, not all the other attributes that we have about the location, just the ID. Just ID, because the ID will be used as a pointer to build the association between the sales transaction and a specific geographical location. Also, expect to see in the sales table a customer ID or customer ID. And this ID is again associating every single transaction with this ID. I don't need to repeat all the information I know about the customer with every single sales transaction. No, all what needs to be repeated is the ID, because I will be using the ID now to go back to the customer table and understand exactly the characteristics of the customer who bought those sales transactions or caused the sales transaction to happen. So expect to see in the fact table a foreign key. That's what in the dimensional table, it's primary key, because that's the main primary key for that table. It's a unique record from the dimensional side. No redundancy. It's a unique record in the dimensional side, but in the fact table will be a foreign key because it is borrowed from the dimensional table to the fact table to build the association between multiple sales transactions with every single record and the dimensional table. Similar to that, we also expect to see in the sales table a product key. Again, to build the association between sales transaction and the product. Similar to that, the salesperson ID, again, to build the association. So all the keys to identify uniqueness, which is IDs in the dimensional table, to identify uniqueness in the dimensional table, will have to be a foreign key in the fact table to build this relationship between the fact and dimensions. Okay, so the relationship is managed by the concept of primary key, P key, FK. If you come across those two acronyms, that's primary key and foreign key. That will take us to what kind of relationships, basically. So technically, between any relationship between any two tables can be one of those categories. Okay, one of those three categories, which is basically one-to-one relationship, which is a very, very straightforward relationship, which means every single record in table A is associated with one record only in table B. Every single record in table B is associated with one record only in table B. So that's why we call it one-to-one relationship between those two tables. The very common scenario in the dimensional model is the second one, which is one-to-many or many-to-one. It depends on where you are reading the relationship. So the relationship between a dimension here and the fact table is one-to-many. So the relationship between a customer and the sales transaction is one-to-many, because from the customer side, I just have one unique record for every single customer in the organization. Then from the fact side,
Ashraf?
Yeah.
Somebody on the chat section is asking a question.
Is foreign key is in the fact table? Yes. Can you explain the primary and foreign key again? Okay. So sorry, I missed that question. So the primary key, guys, primary key is the unique identifier of the table, the unique identification of the table. So every single table should have a a column or a combination of column that can identify the uniqueness of the table. Let us keep it simple now. For all those dimensions, there is a key is responsible for identifying the uniqueness of each record. So in the customer table is the customer key, because every single customer, and instead of referring to the customer, because you cannot use the name, because the name you can have duplicate name. Johnny Smith, for example, we can have multiple customer names with the Johnny Smith. So I cannot use the name as an identifier. I cannot use for example, the address, because the address can has multiple people in the same building. I cannot even use the phone number, because you can have two customers within the same household using the same phone number, like a couple, for example, or a wife and husband, or two people live together in the same house and they use the same phone number. That can happen too. So you need to find a unique identifier for each customer. And the best way to maintain the unique identifier, email can be an ID, for example. It can be. Of course, we don't prefer actually to have like email as a key, but as a matter of fact, it can be considered as an ID. But also email can be shared with multiple people. But the best way to identify what is the primary key is to associate every single person with it as an ID. Your passport number is an ID, because it cannot be repeated. Like no one can share with you the passport number or the driving license code or the SIN number, for example. Those are, or the OHIP number. Sorry, not OHIP. You don't. Sorry, OHIP is our health insurance card in Ontario. Your health number in your province. So those are unique identifiers. Driving license, for example, those are unique identifiers, right? And this is the primary key to identify your uniqueness compared to any other person inside Canada. That's the ID. Now, in the fact table, I don't need to use all your information to identify you with every single sales transaction. I don't need to repeat your information over and over again. I don't need to say, okay, this is Ashraf Ghanems who lives in Mississauga and Ontario, blah, 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 with every single transaction. No, I just need Ashraf's ID. What is ID? What is the unique identifier for Ashraf that I can use with million sales transaction that can be easily used later on to build a relationship between who bought all those sales transactions? Oh, I have the ID is repeated over and over again. I'll go to the dimension table, find this person, then I can build the association and say, yes, all those sales transactions were done by Ashraf. I hope that answers your question. Is that clear? Hugo? Okay, cool. So back to, yeah, welcome. Back to the kind of relationships. We talked about the one-to-one, which is basically every single record in table A is associated with this record in table B and vice versa. Then we talked about the one-to-many and many-to-one. It depends on where you read the relationship. So in this case, for example, if I read the relationship, I say, okay, customer has one-to-many relationship with the sales table, or the dimensions in general has a one-to-many relationship with the sales table. But if I'm reading this relationship backward, say the sales table has many-to-one relationship with the customer. The sales table has many-to-one relationship with the location. The fact has many-to-one relationship with the dimension. So one-to-many or many-to-one is the same thing. It depends on where you are reading actually your relationship. Are you starting from the one side to the many side, or you are starting from the many side to the one side? Okay, so one-to-many and many-to-one, same thing. And the last one, the last but not least here, which is a very critical situation, is the many-to-many, and the very awkward situation, because you may end up with a situation where you logically have two entities that they have many-to-many relationship with between them. Okay, then you have to find a way, because conceptually many-to-many can exist, physically many-to-many cannot be maintained, because it can cause issues. Okay, a typical example of many-to-many relationship, the relationship between a course table and a student table in the education domain. A course table in the database of the educational system is a dimension. It has unique code for every single course, and every single course is listed once. Power BI course, English course, Power Apps course, Power Automate course, and so Excel course, French course, etc. So all the information about the courses are considered the unique record in the course table. On the other side, we have a student table where every single student of us is listed there once. Unique record for every single student. Now, what is the, when I ask you now, what is the conceptually, what is the relationship between the student table and the course table? It's many to many. Why? Because every single course can have one or more students. That's very common. Also, on the other side, every single student can have one or more course associated with the person. There is nothing should technically stop me from being enrolled in the course English and the course in Power BI or Power BI and Excel at the same time. So conceptually, we have many-to-many relationship between those two tables. Physically, it's difficult to maintain. Therefore, if you come across a situation when you have conceptually many-to-many relationship between two tables, you have to break it down into intermediate table. A table that breaks down the relationship, which can be in this scenario is considered as a fact table, which in our business scenario here or our educational scenario here, we consider it the enrollment table. So we need to introduce a new table called the enrollment table, where a primary key from the students is borrowed as a foreign key, and the primary key from the course side is borrowed as a foreign key, and the enrollment table will have additional information about the course. The starting point of the starting date of the course, the end date of the course, the course mode, the delivery, is it online course, is it in-class course, etc. We can have information about the instructor and so on. So if you come across any situation where we have conceptually many-to-many relationship, always think about either you are missing a table that can break down the relationship between those two tables, the many-to-many relationships, or you need to introduce a new table where you need to borrow the primary key from table A and the primary key of the table B as a foreign key and intermediate table to break down the relationship between the many-to-many tables. Okay, I hope that is clear for everyone, the types of relationship. What really matters to us is the second one, which is one-to-many relationship. The first one is also interesting point as well, because technically, if you come across a situation where you have one-to-one relationship between two different tables, that also can strongly suggest to merge those two tables together. Because as a matter of fact, every single record in table A is associated with another record in table B. Every single record in table B is associated with a single record in table A. Then the question is, why do we need to maintain them in two different tables? Why we cannot just merge them, like integrate them together into one new logical entity where we have all the attributes from table A and all the attributes or columns from table B combined together into one longer table that has all the columns for just one record? Because technically there is no reason actually to keep them separate in two different tables as long as it is one-to-one relationships. So always get alerted when you have a logical relationship with one-to-one. Do we really need, is there any value of keeping them separate into two separate tables, or should we merge them together into one logical table that has a longer record for the same record with all the columns from table E and column? I see some questions now coming to the chat. Let me tackle the first one. Does that mean each of the three kind of relationships are connected with a unique identifier? A relationship assumes there is a unique identifier somewhere, always in the one side, of course, right? If you don't have a one side that doesn't have a unique identification, that means you have something missing in your data, because every single table should have a unique identifier. Every single table. even from the many side, even the fact side has a unique identifier, even though we have so much duplications, but the combination of multiple things together can achieve the unique identification in the fact table. So every single table has to have a unique identifier. In the dimension is a straightforward. The IDs is the unique identifier in the dimension. In the fact where all the primary key are considered primary key, foreign keys, so the combination of the foreign keys in the fact table is considered the unique identifier in the fact table. Second question, can two-dimension table have a relationship? Yes, and this is awkward scenario, which is I don't recommend. Try to simplify your relationship and achieve the relationship between different dimensions through the fact. Because the fact can jump between or cross or bridge the relationship or achieve the relationship between multiple dimensions. So you still can maintain the relationship. It's a very good question. Thanks for asking this question, brother. It's not recommended because it can cause a lack of what we call a circular relationship. So try to avoid the relationship between dimensions. The relationship does exist, but through the fact. So one dimension will go and filter the fact, and the fact can go and filter back the other dimension, which is a very it could be advanced topic for you guys. I don't want to get lost of the details, but the relationship inside Power BI, we have a single relationship and both relationship. So in this scenario, to maintain this relationship between the two dimensions, we have to make sure that we have the both relationship to allow the one dimension to filter another dimension using the fact table as an intermediate. I know it can be ambiguous now for so many of you because we haven't seen how this is working in Power BI, and also are still new to this concept. But just simply to answer your question, if you have a relationship between two dimensions, try to avoid this scenario and achieve the relationship through the fact table. That's a very simple term to answer your question. Another question, is it possible to be employed as a data modeler, and what will the role of the data modeler in the workplace? And your explanation many will lead to Snowflake schema place relate to each clearer view. Okay, that's a very loaded question. Amina, I thank you for asking this question. Just an advice for you. In the future, try to break down your questions into multiple questions instead of loading one question with so many areas here, because it can create some confusion. So I'll tackle your loaded question now one by one. So data modeler as a role, it does exist. It does exist. And it used to be a very critical role back in the days. Like when I started my career in early stages, data modeler used to be considered like as a separate role in the organization. And some organization, they still maintain that because it's so loaded role and very critical role. It can make or break the whole analytic solution in so many organizations. Unfortunately, it is now.
Somebody has a question.
Sorry, say it again.
Kuka, I ask a question. His hand is up.
Yeah, but I'm just still answering Amina's question.
Oh, okay, sorry.
So the data role is, the data model is now part of like the data engineering role, just to simplify your answer. And your explanation many will lead to Snowflake schema. Not really the case. It can, but Snowflake is basically, if just to clarify the Snowflake here, in the product table, guys, you have two options. You can consider also all the category and subcategories as part of the product dimension table, or some people, it depends on how many attributes related to the subcategory table and how many attributes related to the category table can be normalized further to extend the product dimensions to have two more or one or more tables on the top of the product table for product subcategories. For example, if we have 10 columns related to subcategories, so push that to another table on the top of the product called subcategories. And if we have another 10 columns on the top of the subcategories at the category level, extend that to a category. So in the dimension that is product here that you see here on the left side, maybe in the Snowflake is not as straightforward as you see here. It can have 3 layers or 3 levels actually. So we start with the product category table, 10 different columns. Then we move to one-to-many relationship with the subcategory because every category has subcategories. Then all the records about all the columns about subcategories. Then we connect the subcategories to a product table where we have all the information about the category, the product. So we can maintain like a hierarchy in the dimensions, 3 different hierarchies or more, of course, into the one dimension in the side of the one dimension. So we extend the dimension to multiple tables instead of just one table. That's the Snowflake. Okay, I need to go fast with the other questions. So Himanshu, or Himanshu, sorry if I mispronounce your name. Would it be possible to create dimensional table from denormalized CSV or Excel sheets? Yes, that's exactly was my intention to do that in the demo, but it seems that we spend longer time on the concept. So we will talk about the next step. But of course, yes, that's exactly the purpose here. Denormalized schema is also same as a star schema. No, okay. Normalization and denormalization is a big topic, right? Because there are multiple levels of normalization as well. One, first normal form, second normal form, or third normal form. There are multiple levels. But the idea, just to simply answer your question, when we do normalize, we tend to merge certain tables together and we consciously accept that the merge of multiple tables can cause redundancy. And that can happen in some scenarios here when it comes to, for example, merging a product category and subcategories in the product table, for example. If we decide to do that, we consciously are denormalizing the category, subcategory, and product table, consciously denormalizing that in one table. So denormalization can happen to simplify so many of fully normalized tables in the transactional source system to become closer to the star schema. So in a loose way, yes, I would answer your question as yes for now, but of course there could be some exceptions. So the friend who is raising his hand, please.
Oh,
You're welcome.
thank you very much. I would have asked earlier before now because it was actually in response to what you said in terms of for us that are new. Speaking about the kinds of relationship, did you say that the focus in our, for example, if you're going to do a report to an audience, you should focus more on breaking down the report to one-on-one relationship, then one-to-many relationship as against many-to-many? I have asked this because I think a report, appetite for a report is dependent on the audience. For example, if you're an investor and you've got businesses in 3 countries, US, Canada, Mexico, at that high level, they may want to see reports that comes from the 3 countries, not necessarily drilling it down to each entity, in this case, in the dimension table to a particular salesman. Instead, they want to see what has Mexico done with the investment we've gone there. That should inform them, okay, in the year 2026, we'll be from our portfolio, we'll be giving more percentage to Mexico because we're making more money from Mexico. So my question is, in summary, is you said we should focus on or did I understand you to say that the focus should be working on the reports that will communicate one-to-one relationship or one-to-many as against many-to-many? So I also think it's dependent on the audience. So that I just wanted to highlight.
It depends not just only on the audience, but it depends on the business of your organization as well. So you have to consider also how the data is captured in your organization and how the data eventually wants to or eventually will be used for reporting purposes. So data modeling is just not an exercise that should be done in isolation from understanding your data source systems or understanding your business process or understanding your business reporting needs. It has to be combined with all those three together. So it's not an exercise that can be done in a closed room. It is exercise that has to be done in collaboration with, again, the source system, the owner of the source system, how the data in the source system and transaction system is captured, how the business process works, and what is the reporting needs and the requirement. So that's the role of the data modeler. That's why it used to be a big role in the past, where we need to bring all those people together and discuss with them when we design actually the dimensional model. But back to your point, one-to-one, guys, again, as I told you, try to avoid that scenario, because always ask a question: what is the purpose of maintaining one record in two different tables? And what stops us from merging those two tables together? Because every single record in table A is associated with one record in table B, and every single record in table B is associated with one record in table B. So the question is, do we really need to maintain them in two different tables or not? Most likely, when you have one-to-one relationship, I strongly suggest actually to merge those two tables in one table to simplify your dimensional model. Many-to-many, as I told you, it's impossible to implement physically because, again, always think about this scenario: student and course, many-to-many relationship. I cannot maintain that physically by bringing the student ID and put it as a foreign key in the class table or the course table, or bring the primary key of the class table and put it as a foreign key in the student table. Either one of those solutions will cause redundancy, which is violating actually the principle of uniqueness of the student table and the class table. The only way is to break down the many-to-many relationship is one-to-many and one-to-many by introducing intermediately table where you can maintain the relationship between a student and the class. So I'm not sure if that answered your question, but I hope that answered your questions. I know
it opens it. It's opened my mind to that. But still, for the benefit of this discussion, for example, I don't know if you've also seen reports that comes from Salesforce. That's visual analysis. Is it a product of Power BI in this context?
Visual analysis of Salesforce, you said?
Yes, the reports that comes from Salesforce that tells you what is being done in the country.
Unfortunately, I don't have any experience with Salesforce, but I can guarantee you it's not Power BI for sure, because Salesforce is another company, and Salesforce acquired Tableau. So 100% I'm quite sure it's not Power BI, because again, Salesforce is the owner of Tableau. So it's impossible to have it as a Power BI report. Two different companies and even two different competitors actually in the market. So it's possible that it is. But it doesn't really matter because those concepts can be applicable to any other tool. All the concepts, guys, we covered so far, as long as we haven't touched Power BI yet, is applicable to the database or data analytics industry in general, because we focus on the concept. We haven't actually touched Power BI yet. I was planning actually to give you a demo actually how to use a flat table and normalize it and build a star schema out of it, but we are already 15 minutes over time. So I leave that to Benga to decide whether he's going to cover that with you in the future session, or do you want me to come in another session, because I don't want this to take any longer. So I leave it to you guys to decide and let me know. So I think, yeah, thank you so much, everyone, for, again, quick recap here for this process. Always keep that in mind. And thanks again. If you have any questions, let me know. And if you want to see me again, I'm happy to come again and give you the demo. Otherwise, please go ahead with your subsequent classes. And thanks, everyone. And please connect with me on LinkedIn. I love to connect with people on LinkedIn, and you can easily find me on LinkedIn. Thanks, everyone. Back to you, Banga, and let me know, please, the next step. Okay, thanks everyone for your feedback. Banga, you are on hold, my friend. I think he's in another meeting. So let us, until he comes back, let us have more questions if you want, guys. I was planning to give you the demo, but we are 15 minutes over already. So if you are interested in the demo and how to actually use the flat table and denormalize the flat table and build actually the star schema inside Power BI, let me know and let Benga know, and I will be happy to come next week as well. In the meantime, if you have questions, let me know. And
Yeah,
connect with me.
yeah, good morning.
Good morning.
Good morning. Yeah, thank you. I don't know what time is it now in Canada. I'm calling from. I'm joining the meeting from US.
US. Okay, which part of the US?
Yes. From Maryland.
Oh, Maryland. Okay, is it East Coast?
Yeah, EST, East Coast.
Okay, so Canada is like the United States, man. We have 5 different zones or 4 different zones in Canada. So, for example, I am based in Toronto, and it's 11:17 a.m. my time. So I'm not sure about your time.
Oh, okay.
What's your time?
Yeah, our time now is 1 second, please. Yeah, it's 16 past 11. 11:16.
Okay. So we are in the same time zone like me. I'm Canada, east side of North America. While those guys, what's your time, guys, in Winnipeg? I think they are.
We're 1 hour behind you.
1 hour. So
10:17.
it's 10:17 in Winnipeg. Yes. Okay. Sorry to interrupt you. So go ahead. What's your question?
No problem. Actually, I'm new in this boot camp, but I quite appreciate you with the little time you spend with us. I see how you break it down for the dimension table, fact table, and all that. But my question goes this way: are we with the little I know about this? I think we have not yet finished about the data model for Power BI. So I don't know. Are you still coming next week, or the meeting continues that way?
Please, discuss that with Benga, because he's the leader of this boot camp. So if you are guys interested actually in a hands-on demo using Power BI next week, let him know and let me know. I will be happy to come next week to give you the demo. I was planning to cover both, to be honest with you, in one session, but it seems that we spend longer time on the concept and we didn't have enough time to the demo. But I will be happy to come next week if you want me to come.
Okay, I will discuss with Mr. Benga. Thank you very much.
You are
Thank
welcome.
you.
You are
Appreciate
welcome. You are welcome, guys. Any other question, guys?
Would you be sharing any material? I know that between you and Benga, maybe some like a slide or just a chat sheet with what we've discussed today, so that some of the things we didn't capture.
Okay, cool. Fair enough. I'll send it to Benga, and he will distribute that and share that with you guys.
Thank you.
And also connect with me on LinkedIn, please. Yeah, if you can find me easily. This is the same picture I use in LinkedIn. It's a very old picture, but I still keep it because that's the picture I use in LinkedIn. So people, they can find me easily on LinkedIn. Any other questions? Was the explanation clear, or especially for those who are new to the concept, was it clear, or did you learn something new today or not?
The teaching was so clear.
Is what? Sorry?
Clear.
Okay, clear. Okay, great. Thank you. Thanks for your feedback, guys. Okay,
Welcome.
I hope Benga will be able to join us back before we leave, but if not, thanks everyone again, and hopefully to see you next week. And all the best with your learning journey in Power BI. Okay, thanks, Aisha. I'll accept your connection right after this meeting. Any other question, guys, before you leave?
Hey, I do have a question.
Sure.
Considering that we have a table plus the relationships already ready in SQL or MySQL, is it possible to import everything to Power BI, or you just import the data and then have to redo all the relationships again?
Okay, that's a good question. Typically, and if it depends on your SQL server. Is your SQL server is the same source table for your transactional front-end system? If the answer is yes, that means that the tables in the SQL server are very normalized tables. Very normalized, meaning what? Meaning there are multiple tables here that you may need to join them or merge them to eventually achieve the star schema. That's assuming your SQL, when you said SQL Server, assuming the SQL Server is your transactional database system as well. In another scenario, the data could be coming from SQL Server, but it is the data warehouse in the SQL Server, where the ETL process took care already of denormalizing tables and building a star schema already in the data warehouse. In this case, you can just bring the fact and dims straightforward from the data warehouse. But if your scenario is your SQL Server is a transactional table, then you have to bring all the relevant tables that you need. Then inside Power BI, you have to make those decisions. Which table can be merged with what table? Because eventually I need to minimize 20 different tables, transactional table. I need to minimize them to, like, for example, 6 or 7 dimensions and fact tables to make it like a star scheme. So the decision to merge those tables together and denormalize certain tables to construct the fact and dimensions has to happen inside Power BI using the Power Query editor. So you have to bring the base tables first, then you make the decision about what to be merged with what to create the dimensions and fact. I hope that answers your question.
I see. Cool. Thank you.
You're welcome. So another question in the chat, there are sometimes when I try to do many-to-many relationship and PBI, it shows that pop-up that doesn't allow the relationship to pull through. Because as I told you, it's not physically possible to maintain a many-to-many relationship. Because as I told you, many-to-many relationship is not a good scenario to handle. Think about again, a course table and the student table. Technically, the course table and the student table, they have many-to-many relationship because a student can be in different courses and every single course has multiple students. So technically, we shouldn't have a many-to-many relationship because how to maintain a relationship is by bringing a primary key from one table to as a foreign key in another table. If you bring the student ID to the course table, it will cause redundancy when the one student is enrolled in multiple courses, right? Because as I told you, I can be enrolled in English course and Excel course at the same time. So you cannot just bring my primary key from the student table to the course table. Also, it doesn't work the other way around. You cannot bring the primary key from the course table as a foreign key in the student table because, again, it can handle one scenario, but it doesn't handle the other scenario without causing redundancy, which is the scenario where the course has multiple students. So the course information will be repeated over and over again. Okay, so therefore, the best way is actually to find intermediate table where you can break down the relationship, the conceptual relationship, a many-to-many relationship into one-to-many relationship, both ends. Because if you try to build a relationship between two tables that they have many-to-many relationship, there is no way to associate every single record from table A with the right record from table B because it creates redundancy, as I mentioned to you. Always keep this example in your mind when you handle many-to-many relationship, course and the student. So many-to-many, it cannot be handled as just a relationship. It's not even recommended to handle it as a relationship. You have to break it down. You have to find a way to break down the table as in and introduce intermediate table, between those two many-to-many tables. I hope that answers your question. Yeah, you are welcome. Hopefully next time, if we have a chance to come for a demo next time, we can tackle some of those use cases and the demo. Okay, don't want you guys to keep you any longer. It seems that Benga is hooked up with another meeting or something, and he will not be able to join us back. So thanks again for being here today. It was a pleasure connecting with you today. And if there is a chance, we can continue our demo and handle some of the use cases inside Power BI next week. Enjoy your Saturday and the rest of your weekend, guys, and all the best. Thanks, everyone.